right, so we're looking at some definitions here, and our definitions really map back to topic 4, domain, codomain, range, and kernel. So domain, just like in topic 4, is our original space that we start in, Rn. The codomain is what we're mapping to, Rm. But the actual values that we get mapped to are our range, and we use this funky R for our range. So we've got our space Rn, and then we map into values in Rm, but these actual values that get mapped to, those make up our range. Okay. Just like before, if we want to find the rank, we can find the dimension of the range. Finding the dimension of the range, we can find our column space. So set up our reduced row echelon and look for the leading ones. We can set it with our homogeneous equation, finding the leading ones again, but it doesn't have to be just the homogeneous equation. We're really just looking at the reduced row echelon form of A. For linear transformations, the kernel is the set of all vectors that map to the 0 vector. So really what we're looking at here is our null space for the function. We find it by setting up our homogeneous equation and solving. In a homomorphism, you'll remember, kernel is the values that map to the identity. Again, nullity is the measure of the dimension of our null space. So here, nullity is the size of the kernel. And then again, nullity plus rank equals n. So in this case, though, our n is the dimension of our domain. So something for us to think about. And then let's look at an example of this. Well, maybe that's not going to move. All right. Find the kernel and the range of the transformation L, hence determine nullity and rank. I'm going to do this in another video so that it doesn't get too long.